Hello everyone, let's look at a trig equation that involves tangent and cotangent. So as you can see here in this equation, it says we want to find the x value so that the tangent x is equal to the cotangent x. And so in this case, because we are getting two different functions, and we'll try to find ways to turn one into the other so that we will have just one type of trig function in the equation. In this case, we choose to turn this cotangent function x into the tangent function so that we can have just the whole equation involving tangent. And of course, you can also turn the tangent into sine over cosine and then the cotangent into cosine over sine. And then you just work with the sine and the cosine functions. But then in this case, it's more convenient if we just convert the cotangent into a tangent. Okay, so let's do this by first using the reciprocal of the tangent. So that's the cotangent, right? So the reciprocal of the tangent x. Okay, so we know that cotangent x is equal to 1 over tangent x. And then the next step is that assuming that tangent x is not equal to 0, right? That and in that case, that's not going to, whatever x value that makes the tangent equal to 0, that's not going to be a solution anyway. So we are going to multiply both sides by tangent x. Then we are getting this equation as multiplying by tangent x here, and then you multiply by tangent x on both sides of the equation and see what happens. You are going to get the tangent x and that tangent x to be cancelled, and so we are going to have tangent x times tangent x on the left hand side of the equation. So we are getting tangent square x, and that's equal to tangent x times 1 over tangent x, because the tangents got cancelled, right? So we are just going to get 1 on the right hand side of the equation. Okay, so now we get tangent square x is equal to 1. And when we get to this step, we have two choices. One choice is that we are just going to do the square rooting on both sides of the equation, and then we are going to get tangent x equals plus or minus 1, or we can simply just move the 1 over and then we factor this. And usually we just try to make the process more systematic here, so I'm just going to move the 1 over. Because when we square root both sides, sometimes it's easy to forget that there was a plus or minus in front of the square root of 1. So if we factor, then we are not going to be missing the other case. Okay, so let's subtract 1 from both sides. Then we are getting tangent square x minus 1, and that's equal to 0. Okay, so now from this equation right here, as you can see, this is just a quadratic equation. And we can actually just pretend that the tangent x, okay, so we are going to pretend that the tangent x is equal to y, right? So we let y be tangent x. And guess what happens? Now the equation will turn into y square minus 1 is equal to 0. So do you see what's going on here? That's actually the difference of two squares, and we can factor this easily by writing it as y plus 1 and then y minus 1. And that's equal to 0 on the right hand side. Okay? So we factor that using the difference of two squares formula. So we can have this y plus 1, y minus 1. And then based on the zero product property, because you have two numbers multiply to get 0, so one of the numbers must be 0, right? So we are going to say that y plus 1 is equal to 0 or y minus 1 is equal to 0. Okay, so we have y plus 1 is equal to 0 or y minus 1 is equal to 0. So now we are breaking it into two cases, as you can see. So we are going to separate that. Probably don't need that much space. Probably up to here will be okay. Yeah, so Move this one a little bit. Yeah. Let's continue with the calculation. At this point, we can actually just solve for y, right? We can move the 1 over, so we are getting y equals, if we're solving for y, then you're going to get y equals -1. And for the other one, it's the same situation here. We have y. If you're adding the 1 to both sides of the equation, then you are going to get y equals 1. Okay, at this point, because the y is already isolated, so we can replace the y with our original function, tangent x, and we put it in here. So that now it becomes tangent x is equal to -1. And the other one is tangent x, and that's equal to a +1. And so in this case, we just need to find the reference angle, and for the value 1 for the tangent, then you know that we can actually just use the same triangle for both cases, because they're both having an absolute value at 1, except that there is a minus sign here. For the minus sign, it indicates the quadrant, so we don't need to worry about that at this point. So to construct that right triangle, we can actually have let's construct that triangle. um, let's just do it on the side. So we construct the triangle, and this would be a 45 45 90 degree triangle, because if you just look at this, look at the ratio here, this one is actually this what, 1 over 1, right? So let me use a different color for this one. This one right here, you can write it as 1 over 1. What does that mean? That means you can just label the triangle by using the opposite over the adjacent. That's what tangent is, right? So we have the opposite over the adjacent, and then we know that because this is a 45 45 90 degree right triangle, then this hypotenuse here would be the square root of 2. Okay, so that what that means is that we are having a 45-degree angle here. That's our reference angle. So for both cases, we are having the same reference angle. It's 45 degrees, so it's going to be pi over 4. So same thing, so let me just put it on the other case as well. No, not pi over 2, it's pi over 4. Okay? And then now, what about the quadrants? The quadrants, let's look at the first case right here. It says that tangent is negative. For tangent that's negative, we are having the quadrants, and if I'm drawing it out, what happens is that if we just label everything right here, then that's all students take calculus. That's an easy way for us to remember. And what's going on here? We look at the quadrants. For tangent being negative, tangent is positive in the first quadrant and the third quadrant. So that means tangent is negative in the second quadrant and the fourth quadrant, right? So we are having quadrant, what is that? We're having quadrant 2 and quadrant 4 for this case. And what about the second case? The second case is tangent is positive, so we have quadrant 1 and quadrant 3. So we are going to get quadrant 1 and then quadrant 3. Okay? So now in this case, we are having, let's see the answer. The answer would be what? We want an angle with a reference angle of pi over 4, and that's also in quadrant 2. And what is that? That's actually 3 pi over 4. So that's our first solution here, 3 pi over 4. And that actually is what? It's 135 degree. What about the other one? The other one is an angle in quadrant 4 with a reference angle of pi over 4. And so that would be 7 pi over 4. And in this case, this is actually 315 degree. Okay, now the other two solutions, we have the one in quadrant 1, so that one is easy. That's actually simply just the same thing as the reference angle. That's pi over 4, and so of course that will be 45 degree. And then the last one, the last solution, it's an angle in quadrant 3. And again, it's having a reference angle power of 4. So we are going to get 5 pi over 4 for that angle. And that angle is 225 degrees. Okay, so we get 4 solutions in this equation. And if you just think about it at the beginning, then you can see why we have the angle in all 4 quadrants, because tangent is equal to its reciprocal. In this case, you just think about tangent being equal to its reciprocal, because tangent and cotangent have the same sign. So if tangent is negative, then cotangent is negative. If tangent is positive, cotangent is also positive. In this case, if they're equal, that means you are going to have all 4 cases to be considered, because if tangent is negative, for example, in this case, then cotangent will also be negative. So then if you plug in the 3 pi over 4 into the equation, then you're getting like the one on both sides of the equation, so they're equal. Same thing for the 7 pi over 4. And on the other hand, we have tangent to be positive, and then of course in that case cotangent would also be positive. So if you plug in the power of 4 in there into the equation, then you are going to just get positive 1 on one side and then positive 1 on the other side. And that's also the same thing for the 5 pi over 4. Okay, so that's it for this problem. If you like my video, please subscribe to my channel and then give me some support. Thank you for watching this video. I will see you next.